This is mathematics, tutorial sheet number 1. So let's start with question number 1, which says let E have the element x, which is a member of integers. You can see that z is an integer such that you have got 1 being less than or equal to x, which is less than or equal to 9. Okay, that's a universal set. And then we've been told that a is x is a member of the universal set such that x is a factor of 12. And then we have got b, which is 1, 3, 4, 5, and 6. So let's first write all our sets here. So the set E, which is the universal set, is a set of integers between 1 and 9. Now, integers are basically counting numbers, which not really only counting numbers. I'll talk about the different types of numbers a bit later on. But integers are all numbers from positive to negative that used for counting. 1, 2, 3, 4, 5, 6. You don't include decimals, you don't include fractions. Okay? It's just those numbers. But of course, a number like 2 can be written as a fraction, is still an integer. Okay. So integers between 1 and 9, we have got 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the integers. And then the set A, we've been told x is a member of the universal set such that x is a factor of 12. Let's start. What are the factors of 12? What numbers can go in 12? That's the meaning of factors. Very good. Excellent. 1. Sorry. Good. 2. Excellent. Anyone? What other number? 3. Very good. Any other? 4. Excellent. The next one? 6. Excellent. Any other? Even 12, right? But it's just that 12 is not part of the universal set, so we'll not include it. Okay, very good. I love you guys. Okay, so that is the set A. And then for the first question here, we want to find A minus C. So remember we said that A minus C is the same as A intersection C complement. Okay, so we'll write it like so. A intersect C complement. If you want, you can first find C complement and then you see where it is meeting with A. Another way you can do it is just tell yourself to say A minus C. Go in the set C. Go in the set A. And then remove all the elements that you can see in the set C. That's the meaning of A minus C. So in the set A, I'm going to remove 2 because it is in C. I remove 4 because it is in C. Those are the only ones. Okay, so what remains is A minus C. That is 1, 3, and 6. But in case you don't want to do that, you can use the formula, the stepwise way. So you have got the set A, which is 1, 2, 3, 4, and 6. And then intersection, we'll find the set C complement. C complement means not in C, but is part of the universal set. So the universal set has got a 1 and it's not in C. The 2, I'll not write it because it's in C. I'll write 3. I'll write 4. I'll not write 5 because it is part of C. I'll write 6. I'll not write 7 because it's part of C. I'll write 8. And then I'll write 9. And then we want now where these two sets are meeting or what is common. So we have got a 1. We have got a 3. We have got a 4. Okay. Now I wrote 4. So 4 isn't supposed to be here, isn't it? Because 4 is in the set C and we want C complement. So 4 is not supposed to be here. I hope we get that. Okay. So 4 is not part of the set C complement. What other element is common? It is a 6, isn't it? So this is the set A intersection C complement. Does this make sense? Is this okay? Anyone that's left behind? Okay, very good. Thank you very much. Thank you for those reactions that I'm seeing. Let's do now B minus A intersection C. So the first thing that we are going to do is find what does B minus A mean. It means B intersection it means B intersection A complement and then intersection C. So B intersection A complement and then intersection C. So the first thing is let's find the set B intersection A complement. Okay. So the set B is 1, 3, 4, 5, and 6. And then we want to intersect it with A complement. The set A complement will look for the elements in the inverse set but not in A. So 1 is in A, so I'll not write it. 2 is in A, I'll not write it. 3 is in A, I'll not write it. 4 is in A, I'll not write it. 5 is not in A. 6 is in A. 7 is not in A. 8 is not in A. 9 is not in A. So that is a complement. And then we want where these two sets are meeting. That will be the intersection. So say therefore B intersection A complement is what is common. You can see there is a 5. Is there anything else? It's just a 5, isn't it? It's only a 5 that's common. And now we want to where this B intersection A complement, where it is intersecting with the set C. And the set C has got the elements 2, 4, 5, 7. Okay, like that. This is the set C. Let me even write it so that you can see that that's the set C. 2, 4, 5, and 7. So anyone, what is the intersection of these two sets? 5. Excellent. All right, very good. Okay, so that is our answer. Let's go to the next one. We want to find A intersection C complement. Now, you can distribute the complement and then it becomes A complement union C complement, but that will be a longer process. So the shorter process is first find A intersection C. Okay. So for the A intersection A intersection C, the set A has got the elements what? 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. And then the set C is 2, 4, 5, and 7. So we want where these guys are intersecting. So that is gonna be 2, 4. Okay, only those two are common. But we want now the complement. So A intersection C complement is going to be, okay, we're going the universal set. Remember the universal set is from 1 up to 9. We'll just remove 2 and 4. So we are going to have 1, 3, 5, 6, 7, 8, and 9. That is that. Is this okay? Are we good? Thank you very much. Okay, thank you, thank you. All right, great. And then we have got A intersection B minus C. Again, this means A intersection B intersection C complement. The first thing that I'm going to do is to find B intersection C complement. Okay. So that is going to be, remember the set B is What's a set B? 1, 3, 4, 5, 6. 1, 3, 5, 6, isn't it? Let's see. 1, 3, 4, 5, 6. And then intersection the set C complement. So remember the set C has got only 2, 4, 5, 7. So just remove 2, 4, 5, 7 from the universal set. So we're going to have 1, 3, 6, 8, and 9. We've removed the 2, 4, 5, and 7. So this is going to give us B intersection C complement being equal to, you can see 1 is common, comma, 3 is common, and 6 is common. Now we want where this set is intersecting with the set A. And the set A is 1, 2, 3, 4, 6. So this is going to give us the intersection. We have got 1, 3, and 6. So that is that. Does that make sense? Excellent. Thank you very much. Okay, thank you. The next one is A minus B is A intersection B complement. And then we have got intersection C complement. Again, we'll first find A intersection B complement. The set A is 1, 2, 3, 4, 6, right? Hope I've not mistaken. I'm not okay, that's the one. And then the set B is, let's see the set B. Okay, 1, 3, 4, 5, 6. 1, 3, 4, 5, 6. So we'll just remove that from the universal set. 1, 3, 4, 5, 6. So we're going to have other elements. That's 2, and then 7, 8, and 9. We've just removed the 1, 3, 4, 5, 6. So where these guys are intersecting, that is going to be, you can see 2 is common. Okay, let me write it down. I'll say A intersection B complement is equal to, we have got 2. I think it's the only one, isn't it? Yeah. And then we are going to say intersection C complement. The set C is 2, 4, 5, 7. So simply remove 2, 4, 5, 7. 1, 3. We'll remove 4 and 5. We have 6. We'll remove 7. We have got 8 and 9. So this is the set C complement 1, 3, 6, 8, 9. Let me write it properly. 1, 3, 6, 8, 9. So therefore, this is going to give us A minus B, which is A intersection B complement, and then intersection C complement being equal to, can you see anything that is common here? What do you think is going to be the answer? Very good. So you can either write Q or just write curly brackets Please don't write interval brackets, write curly brackets. Don't put anything. Don't put even a zero inside. Okay? So that is that. For this last one, for question 1, we'll find A union B first. The set A is 1, 2, 3, 4, and 6. The set B is, what's the set B again? The set B is 1, 3, 4, 5, 1, 3, 4, 5, 6. Okay. 1, 3, 4, 5, 6. Isn't it? I hope I'm not leaving out anything. 1, 3, 4, 5, 6. Yes. So this is going to be the union, remember, is combining. So combine these sets. You have got 1 in the first set, 2 in the first set, 3 in both, 4 in both, 5 in the second, 6 in both. That's a union. Okay. But now we want the complement. So that will be A union B complement. So 1 is already in this set, 2 is already there, 3, 4, 5, 6. So the complement will just be 7, 8, and 9. Does that make sense? Is this okay? Okay, excellent. Question 2 is saying, let A be that set, B that set, C that set, and then Bezo set also. And then verify. So we want to verify. The first one here is known as a, okay, this is the commutative law. Want to verify A intersection B intersection C being equal to A intersection B, then intersection C. So what we'll do is we'll start, this is the left hand side, this is the right hand side. So let's start with the left hand side. Okay. The left hand side, we have got A intersection B intersection C. So this is going to be the set A. The set A is what? 1, 3, 4, 6. We want where it is intersecting with the set B intersection C. Look at B and C. What is common between the two sets? A 4 is common, right? A 6 is common. 8 is common. Okay. So that is that. And then where these two sets are intersecting, that is what? A 4, right? And 6. Okay. So that is the first part. Remember, this is the set A, this is the set B intersection C. And then you go to the right hand side. For the right hand side, it is A intersection B intersection C. So let's start with the A intersection B. What is common between A and B? So in A, okay, 1 is not common, 2 is not common, 3 is not common, 4 is common, and 6 is common. So this is A intersection B. And then intersection, the set C is 1, 4, 5, 6, 8. So this is going to give us, you can see what is common. This is the set C. What is common in these two sets C is just 4 and 6. It's very easy, isn't it? So we'll say, since left hand side is equal to right hand side, hence verified. Okay, that is how you work out this one. So for the second one, now I'm going to ask you to do it. So answer A union B union C, which is equal to A. Oh, the first one. Okay, this bracket is not here. It is like that. Okay, like that. So please verify by doing the same thing that we have done. Next one, we are going to verify this one. I'm also going to get only the first one. For this one, you try, isn't it? Because it's the same. Okay. So we are going to start with the left hand side, which is equal to A union B complement. So this is the De Morgan's law, which we want to verify. So the first thing for us to verify this guy, first find the A union B. The set A is 1, 3, 4, 6. 1, 3, 4, 6. Union. The set B 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And this is gonna give us what we can see is appearing in both sets. We have got a 4 and a 6. Okay. Remember the inverse set is from 1 up to 10. So therefore the complement now, A union B complement is going to be all the elements from 1 up to 10 except 4 and 6. So that will be 1, 2, 3, 5, 7, 8, 9, and 10. So that's on the left hand side. The right hand side is A complement intersection B complement. So the way we are going to work out this one, first find A complement. Remember the set A is 1, 3, 4, 6. So the set A complement will not include 1 in the, we'll just remove 1, 3, 4, 6 in the inverse set. So we're going to have 2, we are going to have 5, we're going to have 7, 8, 9. Okay. Oh, I get. Thank you very much. Our friend has told us something that is very, very important that we didn't do. I was doing the intersection instead of the union for the first part of the question. Thank you very much for that notice that you've seen. Okay. Being used to working with intersection. So we are doing the union. Union is we are combining. So in the first one we have got 3. We also have a 2. I mean we have got a 1 in the first, a 2 in the second, a 3 in the first, a 4 in both. Okay. A 6 in both, 8 in the second, 10 in the second. So the complement 1 is already part of this set, 2 is part, 3 is part, 4, 5 is not part, 6 is part, 7 is not part, 8 is part, 9 is not part. Okay, so that would be the A union B complement. So we have found A complement here. Let's also find B complement. The set B is 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Therefore, the complement will not just include 2, 4, 6, 8, 10. So we're going to have 1, 3, 4 is part of B, 5 is not part of B, 6 is part of B, 7 is not, 8 is part of B, 9 is not, 10 is part of B. Okay? And then now we want where these two guys are intersecting. So A complement, intersection B complement. So you can see 2 is not common, 1 is not common, 3 is not common, 5 is common, 7 is common, 9 is common. So can you see that the left hand side is equal to the right hand side? So since left hand side is equal to right hand side, hence verified. So that is how you get to verify this. And then this second part, I'm asking you, and I'm using the word please for the sake of goodness. So please verify. Okay. Is this okay? Is there anyone that's behind? Or we are moving assiduously together? We are good, right? Excellent. I love you guys. So number 3 is saying, given that the universal set is a set of all real numbers, use the set A from negative infinity to 2, union 3 to 9, and B which is 7 to infinity to verify the De Morgan's laws. Now I'm only going to verify one law of De Morgan's. Okay, I'm going to verify A union B complement being equal to A complement intersection B complement. Okay, that's the one I will verify. So what is the first thing that we are doing? We just go on our set. We are going to find A union B. The set A is from negative infinity up to negative 2. Negative 2 is not being included. Negative infinity is this side. Okay, union 3 to 9. 3 is somewhere there, 9 is going to be somewhere here, and here we are including both. Okay, this is the set A. And then we want the set B. The set B is from 7 to infinity. 7 is going to be somewhere here. And we are including a 7, okay, going in this direction. That's a set B. Now, union means combine these two sets. When you combine these two sets, combining means you are going to have the entire of this part, the entire of this part, including continuing to go forward to up to positive infinity. That's combining. Okay? So meaning that the union is going to be from negative infinity up to negative 2, and then from 3 will actually be shaded all the way up to infinity. So that is A union B. So the complement of A union B, since that negative 2 I didn't shade, okay, let me just make sure that this is proper. Since that negative 2 I didn't shade, for the complement I'm going to shade there. Since at 3 I shaded, for the complement I'll not shade. And then I'll connect them. This is the A union B complement. So therefore, A union B complement is gonna be just from negative 2 to 3. Negative 2 included, 3 not included. Okay? And then I'm going to work out the other part. This part that I did is just the left side. And then let's verify the right side, which is A complement intersection B complement. So first we're gonna find A complement. The set A is from negative infinity to 2, and then from 3 up to 9. Okay, like this. This is the set A. It means the set A complement, since negative 2 wasn't shaded, we are going to shade. The set is, the 3 was shaded, so we'll not shade. We'll connect here. 9 was shaded, so we'll not shade. And then we'll take it this side. So what I've shown is A complement. And then we'll do also B complement. I don't like drawing bend lines because I try, in this life, I try by all means to do what is right. If I've got a partner, it's that one. But them, they cheat. How sure. Anyway, so let's go to the set B. The set B is from 7 to infinity. Okay. 7 is being included and then going to infinity. That's a set B. And then we want B complement. So B complement will actually start from here. We will not shade. We'll be going in this direction. So I'm going to get now the two sets that have got complements and put them on the same number line. Okay. So we are gonna have A complement from 2. So A complement is negative 2 up to 3, and then from 9 up to infinity. That is A complement. And then the set B complement is just from 7 going to the left. That is B complement. So you can see the intersection is just here and here. This is where these two sets are intersecting. Okay. So what is that? Now my mathematics here, there should be something. Okay. On the previous question, I used some wrong numbers. I'll correct them. So this is supposed to be A complement intersection B complement is 2 comma 7. We are not including 7 because it's open, but 2 is included. Let me make a correction on this first part because I wrote negative 2. Negative 2 is not even part of our sets that we are dealing with here. So that was an error that has to be corrected. Sorry. Oh, even this one, yes, this is a 3. So I made a similar mistake also on this part. You see, having data is not enough. Having data is good, but is not good enough. You need to make sure that you have got eyes that are seeing. Okay? So A union B complement. Let's start A union B. The set A, as we said already, 2 going to this side, and then 3 to 9. So that's the set A. We want where it is meeting or intersecting with the set B, which is 7 to infinity. Okay, so 7 is included all the way to infinity. That's it, B. This is not intersection, we're looking for the union. So the union is gonna be from negative infinity up to A2, and then from 3 up to infinity. So this is A union B. But we want the complement of A union B. So it's gonna just be, okay, so this part is included, 3 is included in the union. You can see we've shaded that part. So we'll shade here because it's not included, but we'll open here because it's not because in A union B it was already there. So that will be A union B complement. Therefore A union B complement, we can see it's from 2 to 3. 3 is open, 2 is closed. Okay, and you can see that these are equal, so left hand side is equal to right hand side, hence verified. Is that okay? Excellent. You guys, you are for last. In case you are not okay, there are still more questions. Let x be from negative 20 to 20, a from negative 2 to 7, b from negative 8 to 4, union 8 comma 9, and then c is 3 comma 14. Find each of the following instances and display on the number line. So the first one is c minus b, which is the same as c intersection b complement. So the first is, let's find the set b complement. Okay, for you to find the set b complement, you first need to find the set b. The set B, please, because I've restricted the universal set, the first thing that you need to put on your set is a universal set. Please, please. Unless if they've not restricted it, you don't need to put it. Let's say they've told you the universal set is a set of all real numbers, then there's no worry. So the set B is from negative 8 up to 4, and then 8 and 9. So negative 8 is included, 4 is also included. Can you see 8 and 9? Those are elements. It's not a range. So those you just put dots. Please don't connect those lines. These are curly brackets. They represent elements, not a range. So this is the set B. The set B complement is going to be everything else except what I've shown here. So where there is a closed circle, I'm going to put an open circle. 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 Remember the universal set, we are including positive 20. We are also including negative 20. Simply connect everything that you can see. So connect here as long as it's not part of B. Connect also here. Also connect here. Also connect there. So this is the set B complement. Okay. You are just removing the elements that are in the set B. So you want now where this set is intersecting with the set C. So we can bring it down now. So from negative 20 up to negative 8, and then 4, and then 8, 9, positive 20. So this is shaded. This is not. This is not. This is not. This is not. Then this is shaded. That's our B complement. We want to intersect it with the set C. The set C is 3 to 14. So 3 is going to be somewhere here. 14 will be somewhere here. We are not including 3, but we are including 14. So can you see that the intersection will be from here up to here, up to here, and then up to here. Okay? So we are going to be having this region. We are going to pause at 8. 8 is not part of the intersection because it's not part of B complement. And then we are going to have this. 9 will not be part of the intersection. And then we are going to have this. So the final answer, C minus B, is going to be 4 up to 8. 4 is not part of the intersection, so open. 8 is also not part of the intersection. And then 8 up to 9. And both 8 and 9 are not part of the intersection. And then 9 to 14. 14 is part of the intersection because it's in both sets. So that is C minus B. Anyone who is behind? Yes, please. You can go on. The only part that is not in the intersection are those where there are circles. Okay. Only those portions where there are circles. You can see here. You can see here. Because this is a set C. So the set C and the set B complement is connecting from here all the way up to here. But can you see that 8 is not part of the intersection? Why? Because it's not in B complement. 9 is not part of the intersection. Why? Because it's also not part of B complement. Same with 4. But all the other elements in between, they are part of the intersection. All of them are part of the intersection. All of them are part of the intersection. All of them. Except 4, 8, and 9. But all the way from 4 up to 14, that's part of the intersection. Except that you are pausing on points. So from 4 up to 8, you pause. From 8 to 9, you pause. From 9 to 20, to 14, again, that's where you end. Okay? I know something like this is just a little bit devastating, but it's very easy. Okay, let's do B minus A intersection C. This comma question requires that you just do a bit of more questions. I'm gonna give you more questions, so don't worry much about it, okay? I'll make sure you understand before time. So B minus A intersection C. So this is B intersection A complement intersection C. So we'll start with the A complement. Please follow well, alright? The set A, remember first to put the inverse set -20 up to 20. The set A is from -2 up to 7. -2 is not included. 7 is not also included actually. So this is open. But we want a set A complement. So I'm going to shade here. I'll go to where the inverse set is ending. 20 is part of the inverse set. Also shade here. Then I'm going to go up to here. This is a complement. So I want where A complement is intersecting with the set B. Okay. So I'm going to bring it like so. So that's from -20 up to -2. And then from 7 up to 20. So remember, this is a complement. We want where it is intersecting with the set C. The set C, I mean with the set B. The set B is from -8 up to what? Up to 4. Okay. -8 is open. Please switch off your mic. Up to 4. And then we have got 8 and 9. Okay. This. So can you see this? Please pay attention. Can you see that the intersection is from here up to here? And then also 8 is an intersection and 9 is an intersection because it's appearing in both sets. Can you see that? So therefore, we are going to write this down. So the intersection of A complement and B is from -8 up to -2. Both are included. And then 8 and 9 are also part of the intersection. So that is B intersection A complement. We want where now this set is intersecting with the set C. And the set C is from 3 to 14. So 3 will be somewhere here, 14 will be somewhere there. So 3 to 14, 3 is not included but 14 is. That is a set C. So can you see that C is intersecting with B intersection A complement just here and here. So therefore, the answer for B minus A intersection C is just 8 and 9. It's not a range, those are just elements. So put them in curly brackets. I don't know if you get that. Any question? Alright. These questions are really a lot. Okay. So this one, please answer. Okay, this one is for you to answer. And then for me, I want to do hard things. Okay, let's do this one also. Please answer. Let's do E. It is saying X minus C complement. So this is X intersection C complement, complement, intersection A minus B is A, intersection B, complement. Okay. Let's distribute the complement that is outside. So that is going to give us X complement intersect. Oh, sorry, the sign changes. Remember, when you distribute a complement, you now have a union C with two complements. And then intersection A intersection B complement. Remember, X is the universal set. And I told you that universal set complement is an empty set. So that will be empty set union C. And then intersection A intersection B complement. Empty set union any set is that just that same set. So this is just C intersection A intersection B complement. Okay, so this is what we are doing. But isn't it the same? Okay, so we've already done this question. You can see that it starts basically the same as the first one, B intersection A complement. Okay, this is actually B complement intersection A and then intersection C. So let's answer it. We are starting with the B complement. Please remember, first start with the universal set, which is from negative 20 up to positive 20. Is it hard to put the universal set on the number line? Is it okay? Very good. And then the set B, negative 8 to 4 and 8 and 9. Negative 8 up to 4 and then 8 and 9. So this is included. This is also included. Then we have got 8. We have got also 9. This is the set B complement. Now we want a set B complement. This is the set B. So I'll go at negative 8. I'll put an open circle. And then I'll start going this side. We'll just reach where the universal set is. Negative 20 is part of the universal set, so shade. Then go at 4. Put an open circle. We are going to be going like this. At 80, I'll put an open circle because 8 is part of the set B. We'll continue. At 9, I'll put an open circle because 9 is part of the set B. Then we'll continue. At 20, we could put a close circle because 20 is part of the universal set. So this is B complement. But we want to intersect B complement with A. And the set A is from negative 2 to 7. So I can bring that down. So I've got negative 20 going up to negative 8. And then 4 is pausing somewhere. Also pauses somewhere. Then it ends at positive 20. Paused at 8 and at 9. That's B complement. The set A is from negative 2 to 7. To be from here up to here. And both of them are not included. That's a set A. We want where these two sets are meeting. So it is from here up to here. You can see that? Okay. And then I'm going to take it there. Alright, the A intersection B complement. The one intersecting from 4 up to 7. 4 is not included because it's not in the set B complement. 7 is also not included. So this is A intersection B complement. But we want to see where it is intersects with the set C. The set C is from 3 to 14. What is being included? 3 is included, 14, or 3 is not, 14 is. So 3 is not included, 14 is included. That's a set C. So where are they meeting? It's basically from here up to here. That's the one. So we'll say therefore x minus C complement intersection A minus B is actually 4 up to 7. We are neither including 4 nor 7 because they are open circles there. The last one is simple. Try it. Okay, out. Is this okay, guys? Anyone that is lost? Anyone who is lost? So the secret to being good in sets, just follow steps. Don't try to shorten things because you are going to likely make a mistake. Okay, let's do one of the things that I love doing the most. Simplifying these sets. Let's simplify these sets. We've been told given x and y are sets, simplify as far as possible. We have got x complement union y minus x with a complement on the outside. So distribute the complement outside. We are going to have two complements on x. The sign on the middle changes to an intersection. And then we have got y minus x to also carry a complement. The two complements cancel. We are going to have x intersection. Y minus x is y intersect x complement. Then we have got a complement. So this is going to give us x intersect y complement. Now let's distribute this complement again to the inside. Y complement, it becomes union x complement with another complement. So that is x intersect y complement union x. Now, x complement, here you need to determine which one is a bigger set between x and y complement union x so that you find what the final answer will be. So this is x, this is y. Y complement everything that is outside y. Union x also shade the entire x, including the part that is in y. Can you see that this set, which is y complement union x, is actually bigger than x? When you are taking intersection, you always get a smaller set. So therefore the answer is just x, because this set is way bigger. Actually, x is part of that set. If it was union, we could have taken that same one. Is that okay? The next one is saying y union x intersection y. So just ask yourself which one is a bigger set. So x intersection y is smaller than y. Therefore, y union x intersection y, when you are finding the intersection of a set, you get a smaller set. But when you are finding the union of a set, you get a bigger set. So in this case, y is bigger than x intersection y. So y will be the answer. How? Look at this. This is x, this is y. The intersection is just here on the middle. Okay? So x intersection y is actually inside the set y. So y is a bigger set. So union means you get a bigger set. So we get y. If it was intersection, we could have gotten x intersection y because it's a smaller set. Anyone that's behind? Anyone? Why are you crying? Ask the question. These things are easy. Okay? Okay, I'll repeat on this one. Understand on this one. So we have got x complement union y intersection x complement. Distribute the complement that is on the outside. We are going to have x complement with another complement. The union will change into an intersection. And then we have got y intersection x, it will carry a complement. X complement is just going to be x. And then intersection, I can distribute the complement to the inside. So that will be y complement union x complement. Do you remember the distributive law? So get x-intercept, distribute to the y, and then x-intercept, distribute to the x complement. So that is gonna be x intersection y complement. You get the sign on the middle union x intersection x complement. This gives us x intersection y complement union. A set intersection its complement is an empty set. And any set union an empty set is that same set. So therefore the answer is just x intersection y complement. If it was intersection any set intersection an empty set is an empty set. Why? The same rule that I've told you. When you're intersecting a smaller set with a bigger set, you get a smaller set. And empty set is always a smaller set. That's why when an empty set intersects with any set, the answer is always a empty set. And any set union another set, you always get a bigger set. And empty set is always a small set. So every time you take a union of any set with an empty set, the answer is that same set. I hope you've gotten it. The next question, x intersection y union x intersection y complement. So here we'll use like a distributive law, but we are going backwards. So it's like we are factorizing out x intersect and x intersect. So we are going to have x intersect. In the first bracket will remain with a y, and then we'll get a union on the middle. The second bracket will remain with a y complement. And any set union its own set, the answer is a universal set. A universal set is a big set. So a big set intersection a small set is always a small set. So the answer is just x because it's a smaller set. So that's it. Simplifying sets is the easiest thing you can do. So the last question that we are doing today is question 6, which says using a single Venn diagram illustrates the relationship between the sets of natural numbers, integers, rational numbers, irrational numbers. Let me just give you examples. When it comes to numbers, the biggest set of numbers, the biggest, we call them the complex numbers. Okay? Complex numbers are the biggest. Okay? So every number that you are thinking of, including what you're not thinking of, is a complex number. So for example, anyone, what is the square root of 4? Who can tell me? Wait. What's the square root of 4? Where is Thaisia? Thaisia, are you around? Co- So it's plus or minus 2, not just 2. But now if I ask you, what is the square root of negative 4? What's the answer? Anyone? So it's not there. For children, they will say it's not there. But for adults, we will say it's there. Because square root of negative 4 is the same as the square root of 4 times negative 1. Okay? No, it's not negative 2, because if you say, remember square root means negative 2 times negative 2 should give you negative 4, but that doesn't give you negative 4. Okay, negative 2 is actually the square root of positive 4. Okay, so you can split it like this. And then we can further split this. We're going to have square root of 4 times the square root of negative 1. So what we said is that we'll make it special. We'll say the square root of negative 1 is actually I. So we'll say this is square root of 4 times I. And then square root of 4 is a positive or negative 2. And then we have got I. Therefore, the square root of negative 4 is positive or negative 2i. Those we call them complex numbers. So any number that you think of is that's a topic we'll discuss, don't worry. Okay? So the square root of 9 is 3 or negative 3. But square root of negative 9 is positive 3i or negative 3i. So complex number is the biggest set of numbers. So it includes numbers, any number that you literally think of in your brain. 1, 5, negative 7, okay, 2i, 4 over 2i, all numbers you think of. After the set of complex numbers, we are going to have a set of real numbers. Set of real numbers. Now the set of real numbers, these are numbers except what has got an I. Any other number, as long as it does not have an I. Okay? So basically a real number is part of the complex numbers. Okay? Except that it doesn't have an I. So whether a fraction, 1 over 5, 2.5, 6, negative 4, all numbers, negative, positive fractions, decimals, all those we call them real numbers. And then we have got what we call, so within the real numbers, now we have got smaller numbers. Okay? A complex number is big, a real number is inside the complex number. Inside real numbers, we have what we call the integers. Okay, the integers. Now integers, these are basically counting numbers, negative and positives. Just that, negatives and the positives. So this is where you find the negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and such. You don't include decimals. And then within the real numbers, you also have two sets which don't intersect: rational numbers and irrational numbers. Okay? Rational numbers are basically numbers that you can write as a fraction. So meaning any one number is a rational number. For example, a 2, a 4, a 5 over 7, 7 over 20, even decimal places that end. For example, 2.45, even decimal numbers that don't end but they are repeating. For example, 3.111111111, so we'll put a dash on top. Or 3.14141414, just like that. So we'll put a dash on top of the 14 because it's repeating. So all these are rational numbers. Irrational numbers are those numbers that we cannot express as a fraction. So please take note that rational numbers and irrational numbers don't intersect. So that will be irrational numbers. Can you see that the set of integers is actually inside the set of real numbers, I mean rational numbers. Okay, it will give birth to integers. Now irrational numbers, you can't write them as a fraction. For example, numbers like pi, we'll say 22 over 7. 22 over 7 is not pi, because if we say 22 over 7, that is a fraction. It means that it is a rational number. Now there is actually a man who spent 3 hours just mentioning the numbers after 2.147, like that pi number. 3 hours just saying the numbers. 2.147 dash dash for 3 hours is just saying the numbers without a calculator. Okay? These numbers don't end and they don't repeat and it doesn't terminate. So it is a very big number, it doesn't end. That is pi. So that 22 over 7 is just an approximation. There's also what we call Euler's number. Euler's number. E. You'll be able to see it more when we are using it. When we start, which topic is that? Exponential functions and logarithmic functions. We also have numbers within real numbers, which we call a whole number. Okay? Whole numbers. Now, a whole number is basically within the set of integers. It's inside integers. So, in other words, integers will give birth to whole numbers. because for all numbers, it's basically these integers, but you're only starting from 0, 1, 2, 3, 4, and going like that. So within the set of all numbers, you are going to have a set of what? A set which you call a set of natural numbers. Natural numbers is basically all numbers without a 0. So these ones we call them counting numbers. So 1, 2, 3, 4, 5, you continue like that. Within these same numbers, you also have what you call even numbers. So even numbers will just be okay within within these same one numbers. We have got even numbers, which is basically 0, 2, 4, 6, 8, and like that. And then we have got odd numbers, which is basically 1, 3, 5, 7, 9, and then you continue. We have got also prime numbers, which are numbers that can only be divided by 1 and itself. So 2, 3, 5, 7, 11, and such. Okay, so this is a set of numbers. So we just now want to write a Venn diagram to show the relationship between natural numbers, integers, rational, irrational, and real numbers. So of these numbers that have been mentioned here, real numbers are going to be the biggest set. So when writing, we are going to write like so, okay? The set of real numbers is going to be the biggest set. That is a set of real numbers. Inside the set of real numbers, you have got two sets that don't intersect. You have got a set of rational numbers and a set of irrational numbers. These sets don't intersect. Alright? Inside the set of rational numbers, that's where we have got the other numbers mentioned. So I've got natural, integers, so those two. So we are going to have integers inside. For integers, we use a z. Inside the set of integers, that's where I've got a set of natural numbers, where I use a n like that. Okay, so this is the Venn diagram. Okay, so I'll just write like this. This is for real numbers, and then this is for integers, and then this one is for natural numbers. So basically that.